Hello everyone, my name is Ali Shokri and today I will be presenting our paper ArCode, which is an approach that aims to help programmers correctly implement architectural tactics and patterns. In this talk, I will be providing a high-level overview of the approach, and you may find more details from the paper itself. And during the talk, whenever I use the term architectural concern, I mean architectural patterns and tactics by that. So nowadays, programmers do not create a program from scratch. Rather, they use APIs of frameworks to address architectural concerns in their programs. For instance, in this code sample, the programmer intends to implement a security tactic authentication by using APIs from a popular security framework, the Java-based framework, Jazz. The highlighted lines are where APIs of Jazz are being used in the program. And as it's shown in the code, the API usages are spread over two methods. However, in a real life, more complex programs, there might be hundreds and thousands of classes and methods that they're interconnected to implement a specific tactic. There are also data and control dependencies between these APIs. By data dependency, I mean that the data produced at some part of the program will be used by another part. And by control dependency, I mean that the execution of some part of the program might depend on the execution of another part of the program. And this is the responsibility of programmers to learn how to correctly use APIs and follow these guidelines. However, there are studies that show that incorrect usage of APIs, which we refer to them as API misuses, in 95% of the time result in crashes at runtime. So this is a crucial task for programmers to learn how to correctly use APIs to implement tactics and patterns. However, this is not a trivial task. Studies show that learning from typical sources like API documentations, tutorials, question and answer forums, and so on is error prone. To cover this problem, many API usage pattern miners have been introduced to the community to mine code repositories and extract these API usages from those repositories. Basically, these approaches claim that if API is used frequently in a specific way, that means that that specific way is a correct way of using APIs. Which again, there are some research conducted in this area that indicate that this is not the case. So API recommendation systems enabled by these approaches provide recommendations that contain false positives and false negatives. To address issues with these pattern-based API usage miners, we introduce ArCode, which is an approach that learns correct ways of using APIs to implement architectural concerns from two sources. First, from sample codes that practice a specific framework, which would be the training data, and second, from the source code of the framework itself. Then ArCode analyzes a program under development to find deviations from correct implementation and then provides API recommendations and fixed recommendations. In this talk, due to time constraint, I will be briefly covering three contributions of this paper, including how we create a ground truth about APIs, the graph-based API usage model or GRAM that we create, and the final inferred framework API specification model. To create a ground truth about API usage restrictions, we perform static analysis over the source code of the framework. Then we find some implicit relationships between APIs inside the framework code and create an inter-framework dependency model which represents that what API of the framework is dependent of another API. Since information are extracted from the source code of the framework, this would be considered as the most reliable information that one could extract about APIs. Next, we perform a context-sensitive interprocedural data and control flow analysis on programs in the code repository. We find APIs and their relationships inside the code and create a graph-based representation of API usage for that program. Due to this type of analysis that we perform, even if APIs are spread over different classes and methods, ArCode is enabled to find their dependencies and create the program-wide API usage graph. This graph is specific enough that represents API usages in that specific program, but at the same time is generic enough that eliminates some unnecessary details. For example, in this figure, the created graph shows that before instantiation of an object of login context, instantiation of subject and callback handler has been happened in the code. However, it shows that the order of instantiation of callback handler and subject does not matter and does not affect the behavior of the program. Lastly, we collectively use the created graphs from the previous step and establish specific graph merging rules to find mergeable parts of these grams and create the final framework API specification model or FSpec. This model represents the correct ways of using APIs in a program to implement architectural concerns. As it's shown in this figure, the created FSpec has weights on its edges, which shows that the number of times that ArCode observed the similar graphs. These frequencies, alongside with another measure, graph edit distance, will be used for providing recommendations and rank the recommendations for the program. Well, collecting projects that practice the framework and at the same time has no syntax error, which means that they're compilable, is not a easy task. Though we were able to create a repository of 51 programs that use Jazz framework and 50 programs that use another popular Java-based framework that facilitates remote method invocation, RMI. For our experimental study, we used 80% of these programs as train and 20% of them as test cases. And we compared the performance of ArCode to two state-of-the-art API miners, GrooveMiner and Maple. And there are a couple of experimental evaluations mentioned in the paper. And here I will briefly go over one of them in this presentation. In one of our experiments, we created test cases by eliminating APIs from programs, from the test programs. And we asked ArCode, GrooveMiner, and Maple to analyze the program and provide fixed recommendations. We asked all the three approaches to return a ranked list of 10 recommendations, meaning that the first API in the recommendation list is the one that the approach believes is the most possible API that should be used in that program. Then we computed the top K accuracy for these recommendations, and as results show, ArCode outperforms both approaches in all cases from top 1 to top 10. Here I would like to point out some of the limitations of ArCode. So although ArCode aims to learn correct ways of using APIs to implement architectural tactics and patterns, it cannot guarantee that it learns all the possible correct API usages. Also, in this paper, we presented earlier steps toward finding ground truth from the most reliable source, which is the framework source code. However, we've planned to perform more sophisticated analysis, including symbolic execution and dynamic analysis, to find more inter-framework dependencies from the framework. Finally, we need to emphasize that although the results are promising For the purpose of generalizability, we need to conduct more experiments on both other frameworks and more programs. So in this talk, I briefly covered 3 of the main contributions of our paper ArCode. And you may find more details from the paper. Also, the artifact of the paper is publicly available at its GitHub and Zenodo repository. Please feel free to reach out to us if you have any questions or you're interested in having collaborations in this specific topic. Thank you.